My name is Janusz, and I will show you manual loop closure tool. I have some query from end user, and I hope this movie will respond this query. So this is the short movie showing the data acquisition. You can see some 360 camera and the scenario. So we are going around the city. I will stop here. So you can see that we have some pedestrian area. This is our system. The camera is GoPro. So what we will do now, we will open multi-view TLS registration step second, and our data is organized as a session from lidar odometry component. So we just open the session and we just load session. This session will load sometime, so I will back to our camera. So you will see that this tool will help you to make map of such a pedestrian zone. Maybe I will stop here. So the idea is that we create a technology that will help traversing such pedestrian zones with high precision. Okay, there we go. Okay, let's back to our software. It's almost loaded. The idea in this movie is to show you the basic capability, how to make loop closures and how to use PostGraphSlam to refine all edges, so your map will be more consistent. Okay, so it is loaded. Still some indexing of the data. It is a large data set, so we have to wait a little. Okay, so top view of our data looks like this. So in view, I will change the color of the background. I like the black color as a background, and I will change also the view point cloud as a random, so I can see here. And our tool is manual loop closure. So this is our tool, and then we can start doing our job for loop closure. So let's find certain loop closure candidates. So what I am doing, I am pressing Shift and mouse middle button, so you can see that I can traverse around the trajectory, and Control, so I have two different point clouds candidates to loop closure. So let's add the first one. Let's make manipulate active edge and make ICP to refine this edge. I will repeat it 10 times. I will try to find 10 edges. Then I will export this data set and I will show you the result in CloudCompare. So I will repeat 10 times, so you will see repetitively the same scenario, but every time it is like this. We choose edge, after that we refine with iterative closest point, and finally we have to choose initial poses and compute PostGraphSlam. So let's find another edge. Let's say this one and this one. So we have this edge. Okay, it is quite interesting. So we add edge, then we manipulate active edge. We use Gizmo to manually align. This is not automatic tool. As I wrote in website, we are working on automation, but we have to collect some data sets for AI, so don't worry, it will take long. We would like to work on it this year. So I hope you can also join this project to collect data and share with us. So we have another edge. Okay, and we have to back to compute PostGraphSlam. You will see that it will be refined. Oh, and it is after postgraph slam. Okay, so let's find another one. Maybe this one and this one. So we have chosen the pair. We add edge. We manipulate active edge with gizmo. So we can move it here. Then once you move, do some initial alignment. Then you can use ICP for final refinement. So you can see that it is semi-automatic, but a pair of point clouds has to be chosen manually. So you can see that the automation is not so big problem, but believe me, in in a real world scenario, it is still difficult. We hope to manage this one, but without your help, without some more effort, more people involved, I don't think so that it is an easy case. Let's add edge. Let's make ICP. And we click ICP till it is already refined. So let's back to compute postgraphs now, and we have this one. Okay, so let's find another one, maybe this one. If you have similar color, you can just click again random. So okay, so we have to add edge, then ICP, and you can see that I repeat and repeat this tedious sequence of similar, exactly the same, let's say, functionalities. So you can see that what I am doing every time I am searching the candidate for the loop closure. For example, here and here. Then I am adding edge candidate. Then I will manipulate this active edge with gizmo, for large initial alignment. And then once I am close to the optimum, I am typing ICP on half meter for larger error, then 25 centimeters for smaller error, then ICP 01. And after that, I am computing postgraph slam. And you can see that our system is much better aligned. Okay, maybe we can go here. So this one and this one. It's quite large error, so let's add edge. Let's use gizmo. It's quite interesting case. It's not so easy. Okay, so ICP 0.5 meter, 0.25 and 25 centimeters. Let's take a closer look. I don't think so that it is aligned. Oh yeah, so it is big error. So we can use 1 meter, for example, for this. So you can see that sometimes this ICP also causes certain problems. So it is quite important to be sure that you align and you make quality control by seeing if the system is converging or not. So we back to the compute postgraph slam, and once you are happy with this, we can find another candidate for edge. So maybe here and here. Oh, this is quite small error, but we add this edge. You can see that error is arising once the distance is longer and longer, because lidar odometry has a consecutive error, so you need loop closure to minimize this consecutive error. It is straightforward that edges will help with that. Another option is to use GNS signal, but it will be on another movie. We have this also implemented, but let's focus on the postgraph slam according to our query from end user. Okay, maybe this one. Okay, this is also a very small error. We will not focus on this movie on reducing error to the minimum value. I'm just showing you that how to use this system, this tool to calculate map using PostGraphSlam tool. Okay, so one zoom out and let's find the last session in this system. Maybe this one. So I click with Shift, with Control. You can see that we have candidate. Then we add edge, so you have 9th edge candidate. Once you have a candidate, you can manipulate this candidate by clicking ICP. So you can see that it will converge. It is converged already. So let's make much better result and compute PostGraphSlam. So the last one, but not least, let's find edge candidate. Let's make edge candidate here. It's quite promising place. You can see, oh, I found a very nice place. So what we do, we add edge. You can see this our 10th edge. We manipulate this active edge by gizmo, so you can use this one. And then you can use ICP. Let's start from 1 meter radius. Then we have 0.5. 0.25. 0.1. And let's back to our compute PostGraphSlam tool. Let's make a much wider perspective. Once we click, you have adjusted all errors. So what we can do, we can save our session. We can save session so you have everything stored in your hard drive that you can load again in this tool. Either you can export to CloudCompare data, so you can save all mark scans as global scan. Let's say all PC manual loop closure LAZ, and let's wait a little. We can back to see what we measured. We can back to this pedestrian area, so you will have some imagination what we have visited. So you have typical pedestrian area that we trespass. So it is still saving. So let's back to our video. Obviously speaking, we have some GNSS. This is NAM GPS module. You can use this data to georeference the system, the map later on, but it is not so good receiver. Now we switch to uBlocks X20 and we are much more happy than before. So you can see that it's quite interesting data set. You have plenty of things around you. Okay, so we saved. So let's watch the data in CloudCompare. So you will have entire feedback about the. So we have all, PC. So what we have 176 millions of points. It will take a little to load the data, but during this time I can back to this tool, and what I can show you now, if we go back from this tool by tools manual loop closure, then we have we have some view. So once we decrease number of points, number of decimated points, then you have some preliminary view of the map. This tool is not optimized for viewing. I prefer CloudCompare, it is much faster. But at least here you can see something, what we measured. You can see buildings, you can see trees, streets, trees, and all the objects that you can find in this scenario. We have to wait a long for CloudCompare to load. So if you would like to investigate your edges, you can back to your tool when you have manual loop closure, and then if you manipulate active edge, you can with this button you can simply jump from one edge to another, and you can simply investigate if everything is okay with your system. So you can see that you can watch everything what you did. Obviously speaking, you can add more and more edges, so your map will be much more accurate. But the basic idea is to find largest error, to minimize the error by adding edge in such a situation. So you have 10 edges. In such a typical scenario, I used to have 30 up to 50 edges. There are plenty of opportunities to add another edge. What do we have in CloudCompare? Still not loaded. So let's watch till end our journey, so we will see if we have something interesting. So I asked my student to collect data. We have published a paper, and we offered plenty of such scenarios. We have entire Warsaw city, so we have 30 sessions like this of 5 kilometers, so 30 around more than 100 kilometers. And we are working on the publication now about we are creating a ground truth edges, because we would like to benchmark existing models for that. And if you are satisfied, then we stop. But if we can find certain issues, definitely we will work on it, either by new training, either we will work on new architecture. We will see. I don't know now at this moment what will be the direction. Now our research is focused around collecting data and taking a look about challenges. We have plenty of data, so we can figure out. Yeah. Okay, let's back to the CloudCompare. Almost 97%. 97%. Okay. Now it is indexing data. Let's hope we see something. Oh, this is our system, and we change color. We will change color to intensity from GPS time, and we will change to high contrast, and we can zoom in. So we can see beautifully what was going on. So you can see that we have very nice part of the city, and our system is designed to map cities with extremely affordable mobile mapping system. You can find our system on our website. So you can build your own system, you can use this software, and you can join us in working on this AI automation. I hope within next years we will solve this issue. Believe me or not, it is extremely challenging to figure out all possible scenarios. It's not so obvious. It is working mostly on easy cases, But in reality, we have much more difficulties than we can imagine. That is why we decided to collect as much data as we can, so we can give you some feedback about challenges and research opportunities. Okay, so you have very nice road. It is multi-level construction. So I hope you enjoyed this movie. I hope you will be capable to do similar loop closure, manual loop closure, and I hope you enjoy this system. See you soon in next movie, and please do not hesitate to comment the movie. Do not hesitate to give me feedback. I will be very happy to give you another movie or to give you another let's say overview of this powerful tool. What you can see here, that this mapping tool can deliver you quite nice accuracy and precision. Obviously, it can be better, but at this stage of the development, we are quite happy of it, because you can see at least some structures, and we are focused more on reliability. It means that it's supposed to work rather than being so crazy accurate, but with some other problems. So please give me feedback if you find some issues with that. Okay, I will zoom out, and I think we can stop here. Once again, thank you very much, and once again, do not hesitate to contact me. Thank you. See you soon.